Hi everyone. So today I'd like to talk about finalizers. So just following on from my last video on object references, part 4, I mentioned that I would be doing a video on finalizers, and this is the video. So finalizers themselves have been in Java since the beginning, in Java 1, and it's a callback that's used by the garbage collector when it's about to reclaim an object. So you can see here, for example, the finalizer method in this customer class. So this basically is called when the garbage collector is about to reclaim the memory. And you can see here you have the finalize method, you have the super finalize, although it's better to put it into the finally section of the try catch in case of exceptions. So this is basically the format, the structure of a finalize method. And you can see here that the finalize method should be always overridden from the object class. And you should always call the super class finalize method from your finalize method. And as I mentioned earlier, it should be the finally blocked. And this makes sure that even if the customer class finalize method, the customer object finalize method, throws an exception, then the person object which it inherits from will still get finalized. And this will clean, and normally in the finalize method you clean up any references that you are using in your object, so that it's nothing is left, there's no memory bits that are left in the system. So why do we use finalizing? Well, initially, as the method name suggests, it's the last thing the system will invoke before the garbage collector reclaims the memory. So it cleans up. You're using this to clean up the memory used by your object. So you're enforcing some good memory management practices, and it looks like a nice way to ensure objects are cleaned up when the garbage collector calls the method. And all we have to do is define it and do the necessary tied up in our class, so that as we know what we're doing with our class, the references, and the garbage collector takes care of calling. However, given that we now have it's now been deprecated since Java 9, then there obviously are problems. Well, there must be problems with the finalizer, and this is what I wanted to go through a bit more in detail. And if you go to this link here, then you have so if you look at the this link here in this. So if you look at the link here, then you'll see that there are many points raised for the reasons why the finalizer method has been deprecated. But in a nutshell, I'll summarize some of the problems here, and then I'll show you the actual documentation as well. So the first point is that your cleanup code is on the object that you're trying to clean up. So the finalize method itself is on the object that is being cleaned. So that can give rise to some problems. So and I'll probably talk about it a bit more now. So the first problem is that you can actually resurrect references and store them in a static field on another object, which is quite possible. And then you have a situation where the finalizer method has been called, but the object itself is now referenced by another object, and the finalize method on the first object will never be called. Another reason why the finalizer method has another problem with the finalizer method is that objects are kept alive longer than necessary. It stands to reason that the garbage collector needs to keep track of all the objects that fire a message, and it does that by keeping a reference in the queue. And then at some point, it will then run through and start calling the finalize method on each of these objects. So how it calls these finalize methods is entirely up to the garbage collector. Some may do it sequentially, some may do it concurrently. If it's sequential, then you have a situation where one finalize method could delay others to run. If it's done concurrently, if for some unfortunate reason there's dependency between objects, then that can cause problems as well. But the point is that in the whole scenario, the object is in memory for longer. So if we didn't have a finalize method, if there was another way to get around that, then the object would just be released out of memory and we would need to wait for the garbage collector to invoke this finalize method. And in fact, actually, there is no guarantee that the garbage collector will even get around to calling the finalize method. As I mentioned earlier, you can actually resurrect references in the finalize method so that the object itself lives on, even though the finalize method will then never be called because it's only called once. So that's another example of how the finalize method actually does more harm than good. And it's for this reason that we have the object reference types that have come along to help address these problems with the finalize method. And the best one that as an alternative is the phantom reference, and you can have a look at my video part 4 on phantom references. And the demo that I have in that part 4 as well gives you some insight as to how the finalize method is called, and also how the reclaiming of the memory is slowed down by the fact that the reference that the garbage collector keeps for the object is itself a reference, which means that it can't be deallocated. So in this way, there are many problems with the finalizer method, and this is the reason why it's been deprecated since Java 9. And really, going forward, there are very few reasons to use the finalizer method. Maybe you could do that. You could do some logging from there. But in general, there are better ways to ensure that the objects are cleared up out of memory, and faster ways to ensure that the objects don't lie around in memory for too long. And now I'll just show you briefly the actual documentation. I'll talk a bit more about that. Here is the section that I was talking about earlier on, and when you click on that link you'll come to this page, and here you'll see that it talks about why it's being deprecated. You can see here that it talks about the problems here. You have performance issues, deadlocks, hangs. Performance issues, basically my understanding of this is that, as I mentioned earlier, it takes longer for memory to be released with the finalize pattern of processing. And in a system using a lot of memory, if the memory is taking longer to be released, then it's very possible that the system can run out of memory and crash, and it basically either crash or slow it down, because the garbage collector has to keep running to tidy up and reclaim memory for the rest of the process to carry on. Deadlocks, where you can have problems where one finalizer method depends on another, and that can cause the whole thing to lock and completely freeze, and hangs as well, which is similar to that as well. Errors in finalizers can lead to resource leaks, and there's no way to cancel finalization because it's no longer necessary. And I think that's self-explanatory. No ordering specified among calls to finalize methods of different objects. Yeah, so there's no ordering specified. It's based. There's nothing defined there. And I think probably one of the worst parts is that there's no guarantees regarding the timing of the finalization of the being called. So it might be called, it might be called straight away, it might be called later on. There's no guarantee, and it all depends on the implementation of your JVM and its garbage collector. And that's exactly what it says here. After an indefinite delay, if at all. So really, there are they're quite serious problems with using finalize methods, and the moral of it all is that we should steer well clear of it if we can, especially if you have critical systems that need to have memory cleared fast. And the alternatives here are the phantom reference and the cleaner provides more flexible and efficient ways to release resources when an object becomes unreachable. And you can see here that we've already done a video on phantom reference, which is part 4 of my object reference videos. So I encourage you to have a look at that, and the demo in there is very um, helpful in building your understanding on phantom references, and also on the finalize method, how it's working there and how it can slow down the memory being released to the system. So that's in a nutshell there, a brief video there on finalized methods. Do reach out to me if you want more information, and I hope to see you again next time for another video in the Java interview series. Thank you. Bye.